Let's move on to making plasmid DNA sample and performing DNA gel electrophoresis. First, let's go over the materials needed. You'll want the isolated plasmid from last week. For me, I got plasmid T and plasmid O. For you, it will be one from you and one from your partner. Then you'll have something called LB, loading buffer, from the front, and M, this is the marker. So loading buffer is going to give our plasmid color so we can track it while the gel is running. Marker is going to have already known DNA fragment in there. So as it run out, then we can know how far our DNA ran and what it correlates to. So we'll see that at the end. Then is gel electrophoresis box and the lid. That's the box. This is the lid. The power supply, which looks something like this, with holes for connecting the lead to the box to provide power. And then the pre-made agarose gel, as well as the pre-made 1xTAE, which you did label. Then just grab a beaker and add some DI water from the carboy by the sink. There's the usual things like micropipettes, tips, and the microcentrifuge tube. Then we're ready to start making our samples. Let's make the DNA samples. As a pair, you're going to make one practice sample and 2 plasmid DNA sample, one for each student. 2 students as a pair only need 1 practice sample. So what's in the practice sample? Step 1, you're going to add 40 microliter of DI water and then 10 microliter of the loading buffer. So the practice sample is really just water with coloring dye. And the reason is because we want you guys to get to practice how to load DNA. Okay, so we're going to add 40 microliter, which means you're going to reach for a P200, dial it to 040, grab the right tip, get 40 microliters, put it into the tube that says PS, and then get rid of the tip. Next, you'll need to add 10 microliter, which means you're going to reach for P20, set it to 100. You're going to imagine a 0 between the second and the third digit. So it's going to be 10.0, which really means 10. And then grab the loading buffer and take 10 microliter. There's not a lot in 10. And then add it to your sample. Okay, get rid of the tip. And then you can see how it's not fully mixed. So I would say just flick it with your finger, or you can vortex it, and then now it's nicely mixed. Okay, step 2, prepare plasmid DNA sample by taking 20 microliter of the plasmid DNA from last week, add it into a newly labeled, so I already labeled this one, and I'm going to move from here to here, 20 microliters. So I'm going to reach for my P200, dial it to 020, and then take my plasmid T, take 20 microliter of it, not a lot, add it to my new tube, 20 microliters, get rid of the tip, and then I'm going to move to step 3, add 5 microliters. So I'm going to reach for my P20 and then dial to 050 because that's where 5 microliter is. And then I'm going to take the LB again, which is the loading buffer, and then add it to my 20 microliter of sample. Perfect. And then I'm going to vortex it again. And then my partner will do the same thing for his or her sample. When you're done, you should have 3 samples. One is the practice sample, water with dye. One is your sample with dye, and one is your partner sample with dye. And then there should be still plenty left in yours and your partner's plasmid. Make sure that you return this leftover plasmid to your professor. We need this next week, so return that before you continue. Next step, you're going to examine that your agarose gel is solidified. It should look more opaque like this instead of very clear like when it was first made. Once it's opaque, that means it has solidified, and the first thing you do is use both hands to pull the comb straight out. So you need to be even about this. Okay, and then it has made indentation that we call wells. So that all looks good, and pretend your the other pair has also finished theirs. Then turn the knob to loosen this, so then you can actually remove your gel tray. So then that looks good. And then number 6, transfer the gel with the gel tray. So that's the gel, this is the gel tray, into the gel boxes. And the idea is that you want to make sure the wells are near the black electrode. So make sure that it fit in nicely and the well is with the black electrode. The reason is because we're going to load DNA that is negatively charged, and we want to apply electricity, so actually run towards the positive charge, which is in red or is labeled here. Okay. Next step is we need to make the whole thing conduct. So you're going to see there are wires here and wires here. We're going to conduct the electric current by pouring the 1x TAE buffer. And you're just going to keep pouring until it covers the top and also fills the other end. And that's it. Okay, so it looks about like this. Both reservoir have liquid and it also have a max. So you don't want to go over the max, and it actually also tell you which way it's running. So you always want your sample well to be on this end with the black, and it runs with the black and it runs towards this way. Okay, so I think I can add a little bit more to the max. Perfect. Okay, so then now that it's covered, I can see the well nicely and I'm ready for the next step. Step 8, we're going to practice loading now. And we're going to start from the left and then go towards the right as we load. So we're going to start with actually the practice sample. Remember, the practice sample is really just water with loading buffer. So this is to get students the opportunity to practice actually loading sample into each well. Now, the main thing is this well actually has a really fragile bottom. So you don't want to poke through, then your sample will start leaking from the bottom. But then you don't want to release it before it reaches inside the well. So if this is the well, you want your tip right here. You don't want to puncture through, and you don't want to release it above, because if you release the sample above, it's going to then just float on the side. Okay, so you want your tip right in the middle of the well before you actually release the sample. So let's take a P20 and then dial it to 100, which will give you 10 microliters. And that's where we're gonna start. Now, when you first load, a lot of times your hands are gonna be wobbly, so you can do two things. One is anchor both of your elbows on the bench. That will really stabilize it. And then you're going to hover over and see the wells clearly as you draw 10 microliters. That's all you need. With your elbows on the lab bench, you can use the other hand to stabilize and then insert and press. Do not release. Press 2 and then come out. If you release while inside, you're going to draw it back out, right? So let's see that again. You're going to take sample. You're going to anchor your elbow, and then you're going to then use the other hand to also make sure you stabilize, and then you're going to go in, but you're not going to puncture through. Once you feel you're inside the well, you're going to push 1, 2, and then you're going to come up before you release. Okay, so now you're going to work your way through and load all the wells by you doing 2 of the practice sample, your partner loading the other 2. Now, once you're pretty confident you can do this, student 1's going to load 1 marker and their own DNA sample. Student 2 is going to load 8 microliter, so make sure you dial it correctly, and then 20 microliter of their own sample. When you're all done, it should look something like this. Those are the practice sample. That's your marker, that's your plasmid. That's your partner's marker, that's your partner's plasmid. And then we can move on to the step of placing the lid onto the box. Make sure that you line up black with black and red with red. Close it tightly so the lead can actually connect. And then you're going to connect red to red, black to black. Once it connects, you're going to come to the side, switch on the power, and then make sure you set the right setting. We want 150 volts, so you're going to make sure the lights on the V for volts is selected, and then go up to 150. And then you're going to press run. And I know there's this little guy that is showing a running, and then the light should turn on. Now observe again that when electricity is running through, you should see bubbling on the electrode. That is good indication. The next thing you should double check is that this is called the loading buffer die front. This color should then move towards this way. If somehow it's moving the opposite way, stop it immediately and then ask for your instructor's help. Okay, so we're going to check back in another 5 minutes. 5 minutes into running the gel, you should see the gel die front moving towards the red electrode like this. So double check that and make sure there's still bubble on each electrode and your die front is moving in the right direction. After running the gel for 30 minutes, press this to pause it, and then let's check on our gel. By now, you should see how the die front has reached over about 2/3 of the gel, which means the DNA has separated nicely. So we're ready to image.